Alright, let's take a look at polynomial functions 3.7. So, on these first ones, they want you to graph a polynomial. So, let's get a graph up here. Okay, so there we have our graph. So, if we're looking at this, they want us to sketch it without using technology, which would be kind of tough because they didn't really give us much information. So it's not like it'd be very easy to graph one. So let's take a look at number 1. It says a cubic function with 1, negative, 0 of a multiplicity of 2 and 1 positive. Okay, so cubic, I know its basic shape is going to be like that. Okay, what they told me is that I've got a negative 0 with a multiplicity of 2. So that means it's going to bounce or just touch. Okay, and then 1 positive, which has to have a multiplicity of 1, so that one's going to go through. So it doesn't matter, I'll pick negative 3 and positive 2, and I know my end behavior, I'm going to start clear down here, bounce, then come back through, something like that. Okay, your graph may look different, but that's the basic shape that it's going to have to do. Okay. Now, number 2 says it wants a quartic function. And I hope you guys, before you watch this, you tried some of these. But we've got a quartic function with a negative leading coefficient. Okay, what does that mean? It means that in my function, it's quartic, so it's to the 4th power. This is like the negative leading coefficient. Okay, this number, so it makes it negative. So quartic is an even degree. We know their end behavior is either this or this. Since it's negative, we know it's going to be going down. Okay? It says a positive y-intercept, 1 negative double root, 1 positive 0, and 1 0 at the origin. So we've got a positive 0, a 0 at the origin, and a positive y-intercept. You know what? I'm thinking, because we have a 0 at the origin, that means our y-intercept's at the origin. And because it's a function, I can't have another y-intercept, because then it wouldn't be a function. It couldn't twist around like that. So I'm going to delete one of those. Let's get rid of this one. So 1 negative double root. I'm not sure what they mean by a double root, unless they mean the multiplicity of 2. That's the only thing I can figure. Yeah, that's what I'm going to call it, multiplicity of 2. So negative 1, let's go clear out here. So I know from this end and this end it's going down. I know this one's a multiplicity, so it's going to bounce, come back through, something like that. Okay, now obviously these aren't the best, but you know, we're just kind of going with basic shapes here. Just basic shapes. So, number 3, a cubic function with 0 real roots. Okay. So, real roots are the ones that we see crossing. Okay. If you have a function that never crosses, then they're called imaginary roots. Okay, and we've kind of talked about them, that negative square root. The problem with this one, I'm not liking this 3.7, the notes we did in class or the homework. So it would look probably something like this. Okay, is probably what they're thinking. But I can't imagine a cubic function without at least one real root. Because with its end behavior, right, its basic end behavior is either like that or like that. Well, to get that end behavior, you're going to have to cross the x-axis at some point. So maybe that's what they wanted you thinking. Let's take a look at number 4. Quartic function with 0 real roots, a positive leading coefficient, and a positive y-intercept. Okay, this one sounds more plausible. So its leading coefficient, like this, is positive instead of negative, meaning it's going to go up both ways. So that one doesn't have to cross the x-axis. Now we've got a positive y-intercept somewhere around here. And so something, it could be as simple as going like that. Or you could put some bends in it if you wanted to. You could go woo, woo. Okay. So something similar to that. And there we go with those 4. Let's keep moving on with this homework. Maybe we'll do it all together. Okay, finding factors of polynomial functions. Find all linear factors and sketch the graph of the polynomial function, unless you see another method that allows for quicker graphing. If so, explain method. Okay? Alrighty. First of all, since we didn't cover these too much, let's not worry about that one. Okay, let me grab my graph. So we've got our graph here. Now we're looking for all the linear factors. Okay. And sketching the graph of the polynomial functions. Okay, so if we look at number 5, I've got 2 terms. They both have x's. So what do they share? Well, that's like x times x times x. That's like 5 times x times x. So they share 2 x's. So we can pull out an x squared. If I do that, I'll be left with 1x minus 5. Okay, equals our function. So we've got one of our factors, that's a linear one. That other one is a quadratic one. Okay, if we were to split it up, it would be x times x times x minus 5. Suppose that would be splitting it up to linear. Okay, so those would be our factors. Which factors become zeros, become roots really easy, right? If we set it equal to 0. So we split each one of these up. X equals 0, x equals 0, x minus 5 equals 0, which we could solve by adding 5. So x equals 5. So now, what does it mean when I have these 2 right here? Just kind of like that squared idea, that was like x parentheses squared. So it's multiplicity. So I've got 0 with a multiplicity of 2, and I've got 5 with a multiplicity of 1. So that's going to help me sketch my graph, that multiplicity. That means at my origin, I'm touching. And then at 5, we're going all the way through. Now, it's cubic, so I know my basic shape looks like that. So my end behavior from this one, it's going to be going down this way. From this one, it's going to be going up. So the 0 one, since it's a multiplicity of 2, it's going to touch, kind of bounce off, then we'll swing it back around to go up. So something like that. Okay? It's a good basic shape for it. Alright, so number 5 wasn't too bad. Okay, now number 6. This is one of those special factors. It's called the difference of squares. Because x to the 4th is like x squared squared. And 25 is like 5 squared. The difference of squared, the rule is, if you've got a squared minus b squared, you factor a plus b times a minus b. Okay, that's what we end up doing. So, and the reason it works that way is because of this. If I had x, it's going to be harder to show with that one, isn't it? Say if I had x squared minus 25, that would just be x squared and 5 squared. So if we were to solve it, it'd be like this. We'd have to, if we were to factor it, not solve it, using the box method, you'd have to put a placeholder in for that one. And so we'd end up getting x squared. We'd end up negative 25. And we'd say factors of negative 25 add up to 0. Well, positive 5 and negative 5. Then you'd pull out an x, pull out an x, pull out a negative 5, pull out a positive 5. And it would factor out that way every single time. So they've just made a rule that when you have that situation going on, that's what you end up with. Okay? So, this one would be x squared plus 5 times x squared minus 5. Okay? Now, that essentially gives us our roots. Okay? Because we'd go x squared plus 5 equals 0. So minus 5, so we get x squared equals negative 5. Take the square root of it, we get x equals plus or minus the square root of negative 5. Okay? So we've got a positive square root of negative 5, negative square root of negative 5. Okay? Which that deals with the imaginary roots. Those ones don't cross the x-axis. The other one, however, would work out, right? X squared minus 5 equals 0. Add 5 to both sides and we get x squared equals 5. Square root that. We get x equals plus or minus the square root of 5. Whatever that is. Probably like 2.1, right? Because square root of 4 is 2. So if we're sketching that one, I know at a positive square root of 5 and a negative square root of 5, we're going to end up with those roots. So somewhere in between 2 and 3, positive 2 and 3, negative 2 and 3. Okay. They have a multiplicity of 1. We've got a quartic, which means it's positive. Its end behavior is going to be up and up. So we've also got 2 imaginary roots, which means it's going to have some wiggles in it. But the inside, not too worried about. So we go through. So we start up high, go through, pray, have some sort of wiggle in there, and then go like that. Something like that. Alright. Let's take a look at number 7 now. Now number 7, you could factor it. But it's also, there's an easier way to do this one, right? Because we know what the parent graph is. It's x cubed. Okay, the parent graph is going to have a root at 0, 0, and then negative 1, 1, 1, 1, and it'll look something like this. Okay, well if you recall back when we were first dealing with functions, we had this. That determined if it reflected and how skinny or fat it was. That determined the x value and the shift, the horizontal shift I should say, and then the y value for k was the vertical shift. Well, all we have is a k, a minus 1. So basically, we're just going to move all these points by 1. We're just going to shift it down by 1. So that's an easier way to do it. So I would say using the vertical shift, okay, and parent graph would be an easier way, which, then we can easily see what our factor is, or what our root is. It's going to be a positive 1, so we know that we're going to end up with x plus 1 as one of our factors. And then we probably have an imaginary one somewhere. Okay? And then we said we're not doing number 8, so we'll call that good for this one. Okay, now 9 through 12 talks about using the remainder theorem. Now we didn't really specifically mention the remainder theorem, but when we were checking those factors, we were using the remainder theorem. Okay, so with the remainder theorem, it basically says when we use that long division and we come up with a remainder, that remainder determines if it's a root or not and determines what the point is. Okay, so I'll do the first one the way that they want us to, and the 9 and 11, then I'll show you 10 and 12 kind of with a setup like this, a quicker way to do it. So with 9, we have f of 1, so that means that x equals 1. So it would be x minus 1 would be kind of the factor we're checking, kind of like we did with long division. Kind of work backwards. And we're going to see if we have a remainder of 0 or some other number. If it's 0, it's a root. If it's not 0, it's not a root. Okay, so x, to get x cubed, we go x squared times x gives us x cubed, x squared times negative 1, negative x squared, negative 1x squared. Minus that, 5 minus a negative 1 gives us 6x squared. Bring down the 2x. X to become 6x squared, we have to add 6x, or times by 6x. 6x times x gives us 6x squared. 6x times negative 1, negative 6x. Then we minus. That becomes 0. 2 minus a negative 6. Remember, that's like positive. So we get 8x minus 8. So we times by an 8. 8 times x gives us 8x. 8 times 1 minus 8. Subtract that, we get 0. Okay, so the remainder theorem basically says whatever this number is right here, that's what this is going to be equal to. That's really all it's talking about. Okay, since it's 0, we know that that means it is a root. So yes, this is a root. Okay, so then we can use that to find the others, right? We know now this times this is going to equal this. So I can write it, x minus 1 times x squared plus 6x plus 8. Then we can factor out that other one, okay, using quick box method. So we get x squared, we get 8. Factors of 8 that add up to 6 would be a positive 4 and a positive 2. So pull out an x, pull out an x, pull out a positive 2, and a positive 4. So we get x plus 2, x plus 4. So what are my other roots? Well, negative 2 and negative 4 and our positive 1. And there we found all our roots. Okay, now number 11, we'll treat it the same way. Okay, it's a negative 3, so that's like that's like x plus 3. So I'd go x plus 3 into x cubed minus 19x minus 30. Okay. Oh, and we don't have a square term. Remember, you have to line it up. It always has to have all the pieces. So plus 0x squared, then minus 19x, then minus 30. Sometimes you have to add those in. So multiply by an x squared to get x cubed plus 3x squared. Subtract it, get a negative 3x squared. Bring down a negative 19x. So negative 3x is what we're going to have to multiply by. Negative 3x squared minus 9x. Subtract. So that cancels. That becomes like a plus. So negative 19 plus 9 would give us negative 10x. Bring down a negative 30. Okay. And we'd have to multiply by negative 10. So we'd get negative 10x minus 30. So it becomes 0. So that's a factor. Then to finish it off, we know that this, so yes, the factor, it's a root. So we get x squared minus 3x minus 10. Then we could try to factor that out. Negative 10 x squared, factors of negative 10 that become negative 3, 5 and 2, negative 5x, positive 2x. So x, negative 5, positive 2, and x. So we end up with x plus 3 times x plus 2 times x minus 5. So we've got a negative 2, positive 5, Okay, so that works really well for finding the other factors. If all you were doing was looking for the roots on 10 and 12, you could just plug this in for x and see if it comes up to equal 0. If all you had to do was that, then that would be a quicker way to just plug it in and find out what it becomes. 2 squared is 4, times 2 is 8, plus 18 minus 18. Yeah, 0, 0. Okay. So yeah, I know that one's a root, but that doesn't help me find the other factors. That's where the long division becomes more helpful. Okay? So I'll let you do number 10 on your own. Got to give you one to try on your own. Number 12, I'll remind you what we do here. So it would be x minus 1. That would make it x minus 1. Then it would go into x cubed plus 0x squared, right? We got to put in that placeholder one. Minus 2x minus 10. So then you could solve it out that way and go from there. Okay? I'm going to let you guys work on that one. Alright, now these ones we want to write them in standard form. Okay? When given the leading coefficient and the zeros of the function. So this we hold on to the end. These we rewrite. So we've got x minus 2 times x minus square root of 2 times x plus square root of 2. Okay? So, we start by multiplying. So we get x times x. I'm going to do that one first. Gives us x squared. X times square root of 2, 2 x root 2, then negative square root of 2 times x minus x root 2, then negative square root of 2 times square root of 2. Whenever you multiply something like this, basically you just get rid of those and you end up with 2. Okay? So it would be minus 2. Well, those will cancel out. So we end up with x minus 2 times x squared minus 2. Multiply that, we get x cubed. Multiply that, negative 2x, negative 2x squared, and positive 4. Okay, then it said we had a leading coefficient of positive 2, so that means that that's going to, basically, we're going to multiply all of this by 2 to get our final answer. So we get 2x cubed, and let's do this in order, minus 4x squared, minus 4x, plus 8. And that's what it looks like. Okay? Don't worry about doing 15. You can try number 14. I'll hurry do that one. I think I've got time. I'm almost running out of time. I only got 30 minutes. So we'd have x minus 1 times x plus, let's think backwards here. So we end up with x equals 1 plus square root of 3. Okay? So, if we subtract that 1, we get x minus 1 equals the square root of 3. If we square it, we end up with x minus 1 squared equals 3. Okay, thought that would be more helpful to try to simplify it, but it's not. So we could just go x plus 1 plus square root of 3 times x plus 1 minus square root of 3. So we've got a trinomial essentially right there. So we multiply x times x, we get x squared, x times 1, 1x, minus x times the square root of 3. Then 1 times x gives us x, 1 times 1 gives us 1, 1 times the square root of 3 gives us square root of 3, I ran out of space, plus square root of 3 times x, plus square root of 3 plus square root of 3 times the negative square root of 3 would be a negative 3. Then we cancel what isn't the same. So we've got x minus 1 times x squared. Let's see. We've got 1x and an x. So that would be plus 2x. Negative x squared root of 3 positive cancel out to 0. So does negative square root of 3 and positive square root of 3. Got a positive 1 and a negative 3, so negative 2. Then we can multiply here. X times x squared gives us x cubed plus 2x squared minus 2x minus x squared minus 2x plus 2 when we multiply that one. So we get x cubed, let's see, 2x minus 1x squared would be plus just 1x squared, negative 2x, negative 2, negative 4x plus 2. Then it has a leading coefficient of negative 1, so we basically just change the sign on everything. And there we go. That's our function. So quite a bit of work for that one, huh? Alright, now number 16, we'll talk more about this in class, but if you can, try to fill it out. So we'll call that good. And we're done.